Good morning, everyone. This is Lalit. I'm a solution architect with Amazon Web Services. Today, we are going to talk about how development happens in AWS environment. And to make it more practical, we also have one of our partner, which is MapmyIndia. MapmyIndia is a leading organization that does digitize all locations, and they have even solution where they can map even every building, every floor. They have map for every door, so they like take you from door to door. We'll also see an example in the second half of presentation how you could leverage their API. So without further delay, we'll get started on it. An AWS platform, everything is API. Everything is an API. If I have to define AWS platform, I would say it's a collection of thousands of API. A lot of people might say that there are various services, various resources on AWS. I would say it's a collection of hundreds, thousands of API which you could use. So, and that's what a developer need. If we can have our API, we know how to talk and connect to different systems. When we are going ahead with development in a typical development environment, if you look how a lot of people start with is kind of a single server or a monolithic application, where we do have something like one single server where we are running everything, and we typically vertically scale it and have a connected database with the server. Then we also have some front end to it where end user will connect. So we expose HTML through World Wide Web and provide APIs for users to interact. There's also could be other things like third-party providers which are putting information, a JSON data or XML data. So an application will have two ends, one where the end user will connect, consume the application, and there could be other providers in application. You have written an application, have integrated services from another provider. For example, let's say you're building a location-based service while your application is connecting, let's say it's a delivery solution where you're trying to solve delivery challenges, logistic challenges, but then you also require a capability to map locations. How do you map different location? How do you reach to multiple location? How do you identify where you have to go? That information might be coming from a third party. And then of course there are other integration points. It's not just single integration point. Your application actually might be integrating with a lot of third parties, and it's your application at the end might become a combination of multiple APIs, your core application, which is interacting with other APIs. Looks like there's a slight delay on the slide, so I'll try to go a little slow. Consider you're building an application today, and while we are building application, typically we have seen that application could be a monolithic architecture where we have a combined code base which is running on a server. Consider an application where we are looking at something like a kind of a travel buddy kind of application where you could book your flights, you could book your hotels, you could book cabs, and various other sightseeing tours kind of services. Now, this application have a lot of things in it. It has a flight API so that it goes and connect to various flight portals, get the pricing from Indigo, maybe SpiceJet and other things, and hotel listing. Probably it goes and query Make My Trip or Go Ibibo kind of setup, or Expedia, and then it becomes a combination while your core application is creating an itinerary for a particular user. But then how does it really look like on AWS? How you can quickly set up an end-to-end DevOps tool chain for your monolith? When it comes to the first starting point for a developer is how do they develop? How do they collaborate with each other? How do they manage their software delivery? How their pipeline is being managed? There could be multiple project templates which they are choosing. So AWS CodeStar provide one single consolidated view where you can build, deploy, and roll out your application. So it has multiple services like build service, deploy service, which has deployment adapter and can deploy to multiple servers, and it has a complete pipeline. Now, coming back to our architecture, which is could be, let's say we started with a single vertically scaled server, and it's a same code base, it's a single code base which we have, and it has a connection to database. But then essentially that kind of mechanism is a monolithic example, something like we build on single server and then probably while we are considering cloud, we move exactly the same thing. We consider another server in the cloud and it's kind of a lift and shift and we move to cloud. This is how it will look like. But then this is not something that we are looking forward to. We have more complexities within the application. An application which might be monolithic, but there could be multiple moving components, like there could be a message queue. There could be a notification passing between multiple components of the software. Database, for example, there could be a read write master, and there could be a read replica serving for read request. So an application is not just like a simple monolithic application, it's actually a collection of multiple API calls, which we today might not be designing as an API call, rather than it's a single code base, and everyone has a responsibility to manage that. But there are certain challenges with this kind of approach. How do we manage the state of the application? It's tightly coupled application. There's no separation of concern. If there's a fault in one part of application, then the entire application fails. If there's a performance issues, or it's difficult to solve performance issues because we have to identify a challenge or the monitoring parameter. One thing can break down the entire application. Maintenance is difficult. So there are multiple challenges. How do you manage data tier for a monolithic application, or probably we're writing everything to one single database, while we could actually scale out the request in our database. There could be multiple parts where we require maybe a relational database for strong asset compliance, and then there could be something like a key value store, which is we require for quick lookup or aggregation. Now the solution towards it is Amazon Elastic Beanstalk is a platform as a service where you could simply take your code and deploy it in Amazon. Let's say if you have a deadline to meet that you have to migrate to cloud and you quickly want to get started with cloud with a platform as a service, you could just bring in your code and we can get started with that quickly. However, that's not our end goal. Our end goal is to make the application more agile, which we do through creation of microservices. Now, think of this as we're going to break our application into multiple parts, and each individual part could be developed separately and could be structured separately. Each individual part will have separate ownership. Now, one of the solution is, as we see on the current slide, either we do a lift and shift, use something like platform as a service, or then we start moving to the direction of microservice, where we use something like Lambda. Lambda is a compute paradigm where we don't run any server. It's completely serverless. Behind the scene, we run a container where you supply your code. So you don't have to set up the container. All you have to do is supply your code, and we run the container in response to an event. For example, let's say you have a order booking app. The example that we are taking, travel booking. The travel booking application where we are making a booking. So a booking is an event. When this event happens, only then the Lambda runs. So you don't really need to run your server 24/7. You don't need to patch your server. All you have to focus on your code. And how do you manage APIs around them? The API gateway becomes your front end where you could whitelist your customers or your partners, and you could also throttle, you could put a rate limiting in API gateway. You could even create plans. You could even create plans for your APIs. Moving on, how does you really start then? The very first point I would say is start looking at services which are like code commit, code build, code pipeline. These are part of a code star services where you could start writing your code within Amazon. One of the advantages your code does not leak out and it's secure. You can encrypt your code repositories, and the same code could be automated to go through a pipeline and get deployed in your infrastructure. Now, while doing lift and shift is okay, re-architecting your application into microservice takes little more effort, where you have to really identify how you're going to break down your application, how you're going to identify various components of your application. Some example of from a monolith, which is a simple deployment, we want to move to a partial deployment model where for every component, there is a separate ownership by a single development team rather than like a monolithic application, which is owned by everyone. From a service perspective, a microservice, there is a graceful degradation, while in a monolith, it's a binary failure. And you can scale individual microservices. For example, let's say Amazon.in, there would be more number of user visiting and looking at the inventory or doing search on Amazon.in, and there will be less number of people who are actually making the actual transaction. So you spend a lot of time looking at products, and there would be less number of people who would be buying it at any point of time. So probably we need to scale our inventory search capability. Behind the scene, there might be Solar or Elasticsearch running. So that's where we require the scale. And our transaction system, which could be a cart management, which could be running probably a DynamoDB, a NoSQL kind of technology. And the actual transactions which are happening are less. So we can now scale them individually. We don't really need to scale every part of application when the load comes in, because the user will hit the different part of application now. And we can develop these parts separately. We have a principle called a two-pizza team. For a microservice, it's recommended that a team should be as big as they could be fed by two pizzas. The concept here is that we keep an agile team which can take their independent decisions and build their own microservices. They have a freedom to choose the technology. One of the, let's say, the user interface, the authentication mechanism could be written in a different language, and then there could be other language which could be used for implementing cart system. Checkout could be a different programming language as well. So just like old object-oriented code, there's a low degree of coupling, but these services are highly cohesive and data-driven. They pass messages between each other and act on triggers and messages. So it's not just a technology change when we talk about microservices. It's also a business change, how we do the business. Coming back to our example that we're taking, that we are creating trip for people, where we have flight information, we have hotel information, we're combining all that information and providing a unified experience. But then the people who are booking the flight, they might not be all the people booking hotels as well. So we can scale flight operation and hotels independently. But then do we really need to do that? All we are doing is we are actually calling API for flights and separate API call for hotels. So now the solution for this is really a combination of serverless services, which is Lambda, so that you don't have to really focus on managing your code, focus on managing infrastructure. Rather, you focus on managing your code and enhancing the features in your application. An API gateway to front end it. Any request that comes in gets authenticated, and you can build your consumption plan in API gateway. Do the rate limiting with API gateway. So this is how we move to a microservice kind of model, where everything become, we call it like polyglot microservices. Different services uses different languages. So now on this microservices, for example, when we say one of the interface could be built with a different language, flight services could be built maybe with Node.js, and hotel service might have been built with Java, while trip search or inventory or sightseeing could be written in a different language altogether. So this is how typically a microservice architecture will look like. There would be a load balancer, and there would be a UI through which we hit the API gateway, and behind the scene, the API gateway will talk to individual services, which could be flight service, which has its own database, hotel service that has its own database. Now the question that comes is how I'm storing my data for different services. Then we also require polyglot persistence. And what kind of database I require? Do I need a relational database for all my services, or can I also use a NoSQL database? For example, searching a quick lookup. Do I really need a relational database? No. Probably we can do with a NoSQL database, where we quickly want to search what all options are there, how many flights are there, or how many hotels are there, those kind of things. And for my searches, for heavily queried, or for example, let's say Singapore is one of the popular location, then the results could be cached as well. So at the database layer as well, there are multiple choices. It makes us free to choose caching layer, relational database, or NoSQL database at database layer. And they all can scale independently to optimize its scale for performance and cost. So this is how we build application today. We use serverless compute, and then we use different kind of databases. Now the question comes on monitoring. How do we monitor microservices? Then there is also a concept of distributed traceability. We need to capture a metric for each service. AWS X-ray is a service with which we can instrument your application. We can actually see the user behavior. We can get the traces from the application. So we can even create a map like this, service map, where each service is connecting to another service. We could get stats for each individual services. If one of the service fails, we exactly know where there was an issue. We exactly trace the root cause of the issue. This could also be used to figure out key matrices like response time. How much is the response time? How many milliseconds? How much is the latency? What is the response code? So this is how people are developing differently on cloud, rather than just starting with standing up a simple server, hardening the OS, adding required packages, and then deploying their application and then trying to scale the complete server. Rather than people are trying to do things differently, they're moving towards statelessness, serverless and serviceful things. So I would say think differently when you are developing now, rather than repeating the same old infrastructure setup. Why not automate? Why not use things like CloudFormation, where you could use infrastructure as a code, and you could actually deploy these services again and again. And if you have to change something, you change in the code. So your infrastructure also becomes a code. Think of using something like Lambda, which is completely serverless, where all your focus is on your application, on your code, and you don't worry about the heavy lifting of setting up the infrastructure. So rethink your constraints of how you want to scale. Go ahead and we do have a lot of demos on GitHub. Search on AWS Labs GitHub, and there are examples for Lambda. How do we build a completely serverless application? And these skills will take you a long way, because these are the new skill set which is required. Every other organization wants to scale their operation, and for that it is required that you manage your state separately. Everyone is going towards a microservice model so that we can scale these applications. But then while we are building a microservice model, that means we are essentially consuming different APIs within our application. Do we really need to build everything from scratch? There are lots of API which are available. One of such API is from MapmyIndia, which actually maps every demography. Let's say you're building a logistic application and you need to deliver packages to from one location to another location. While a lot of map will give you the nearby location, how do you go from one door to another door? So MapmyIndia has digitized every location, every building has a number, and it's in a JSON. You can get it in a JSON format. You can parse it in your application, and you could actually identify each door. That means every house, every floor in a building you can identify. So think differently, that rather than building everything on your own, probably you can build a set of APIs and consume other APIs. With this, now we'll move to the second part of our presentation, where we have uh, Sanjay from MapmyIndia, who's going to talk about how a developer could leverage MapmyIndia APIs in their application. And they have a small demo as well, how they have uh, done mapping from door to door, how they have just gone ahead from a simple map which takes you to a location to a particular building and particular door number. With this, we'll change over, and Sanjay is going to present now. So I'll pass it on to Sanjay. Sanjay is a VP for products in MapmyIndia. Yeah, let's go ahead and bring in Sanjay. Thanks.
Thank you, Lalit. Thanks a lot for making us understand this wonderful AWS gamut. Thank you all for joining this particular webinar, and a warm welcome from MapmyIndia family. I would like to share something about MapmyIndia. We believe we take you to doors. Har pata hame hai pata. As a MapmyIndia family, we extend our passion for location to IoT devices and apps. We are dedicated to providing users a seamless experience across devices and focused on delivering breakthrough innovation in the areas of tracking, safety, exploration, navigation, in-car entertainment, or any place, any app where location is the intricate or granular requirement. So let's begin with the company overview. MapmyIndia is actually founded in year 1992, and it was founded by the two visionaries, Mr. Rakesh Verma and Mrs. Rashmi Verma. We are more than 1,000 plus employees right now and having a consumer base of more than 10 million right now. We have enterprise clients, which is 5,000 plus, and we are headquartered in New Delhi. And we have investors, which are Flipkart, Qualcomm, and Zenrin. I think there is a lag in the presentation. So let me tell you the mission of MapmyIndia. We believe that we want to make our world better through maps and location technologies. And the vision is to create the most advanced and accurate and unparalleled map data for India. Our approach is basically, we use our map data as a base to build powerful location, intelligent offerings for consumers and enterprise using the following four as areas of innovation. So basically the four pillars which are there with MapmyIndia are: number one, maps; number two, navigation; then telematics plays a very critical role; and then we have analytics. The basic main aim for MapmyIndia is to democratize data access to millions of enterprises, consumers, startups, and governments. And we are fully equipped to serve extremely large computational needs of large companies. Let's have a look at the kind of variety, the evolution which was there with MapmyIndia. So in 1992, we started with cartography, where actually we were talking about physical maps. And because at that point in time, maps were something which was required, but probably the importance, the kind of criticality was not at that point in time. But the visionaries actually identified that, and then we moved on to GIS digital maps, which was way into early 2000. We then came up with 3D navigation map, which was in year 2007, and then we came up with 360-degree panoramic outdoor maps. During this time, the PND devices for vehicle was there, and we have you utilize that particular thing to create 360-degree panoramic views. We came up with ADAS, which is advanced driver assistance system, which actually gives you slope information, curvatures, lane warning. This kind of extensive data is there with us. Then there was a critical need for laser maps, where we had this laser map which uses lidar. It enhanced photogeometry, and it is used to measure heights of the building. It is used to identify lanes. Then the evolution was for advanced video maps, where we geotag the map video. The video streaming is having embedded geotagging within that, and this all contributes to real view digital twin. This digital twin can be used for AR, basically augmented reality solutions, such as driverless vehicles. Now I want to take you to the next thing, the kind of data, the kind of power which we are having. It is having all the layers. You can see we have addresses, administrative blocks, then we have different transportation networks, land cover, point of interest, be it 3D data, route guidance, traffic, or even regional content at a very granular level. So we have all kind of data. Now let's understand that, okay, this data is there, but how exactly we can empower our end users to, give the power of this data. Because API is something which can be built by everybody, but the main component or the main ingredient for any kind of a service, as shared by Lalit, is the kind of experience which the ultimate user will get. So APIs, if they are powered with the right data, is something which is very, very important for us. So we have leveraged AWS tech stack. So this is how our tech stack looks like. So at the very bottom, we have this feature-rich map data, which includes India and its neighboring countries, be it Sri Lanka, Nepal, Bhutan, Bangladesh. Then on top of it, I mean, it is kind of a data lake is created at the bottom layer. Then we have our mapping platform. This mapping platform and IoT platform is there because there's a lot of data which is coming in from different systems. Then we have our own surveys, we have our own data capturing mechanisms. And the most important piece is that when you have humongous data at that point in time, how exactly you can leverage the data, because the computational requirement is very huge. So what we did was we actually leveraged and AWS, and we actually utilized hundreds of computers. So right now we work on serverless architecture and optimally utilize the data computing. So hundreds of computers are using serverless architecture. At the same time, because we have to innovate, and this innovation requires a lot of experiment, R&D, and some kind of POCs also. And we believe that your initial cost to set up everything is very huge. So basically, we believe in pay as you go. So same thing we offer to our end customers also, where APIs are being offered freely, as well as pay as you go. Let's say if you want to increase your things. So similarly, we utilize the AWS pay as you go process, where we can experiment, we can do R&D, and we can take this thing to next level. We have, so at the middle tier, you can see we have a very complex and a very powerful scalable IoT platform. We have mapping platform. On top of it, APIs and SDKs are available for developer community so that they can actually leverage the variety of data which is available with location intelligence. And on top of it, we have standard MMI products, MMI standard solutions. We have point solutions also. And now there is a third gamut, which is third-party applications, where developer community, where startups can actually come, can register, and can actually work on top of the data which is available. So let's understand what are the things we offer when we actually, host an API. And the most critical piece is the security. And we actually provide security. So we utilize the AWS inbuilt services in accordance with the industry's highest and strict security best practices. There is uptime assurance because we know that, okay, what exactly is there, and we can actually go for X-ray, we can actually monitor things, and we can actually see that the high availability is there, and uptime is ensured for the customer. So this means there is no glitch from your end, and you can actually leverage the existing data and API which is available there. Then the most important piece, I mean, just think of a situation where, we have data which is getting into the system, which is fed back into the system from different sources. We are able to do regular POI updates, which is very fast and frequent. HA and fault tolerance comes by design, and we are elastic, scalable, and cost effective, which is actually delivered to the end customers. And when we talk about APIs, at that point in time, the response time is something which is very, very important. I mean, as a developer, I just cannot go and I can expect an infinite time delay in the response. So with this data and the kind of architecture which we have implemented here, we know that we'll be getting faster response times than ever. We have monitoring systems. Security is 256-bit or 204-bit, and whatever you want, we have that kind of a model. We have a very advanced natural language searches enabled, which, where we can actually leverage that particular thing. The most important for a developer or a technical person is versioning and documentation. We have standardized versioning with backward compatibility, where we know that, yes, you are safe in our hands, even though we are providing you the best versions, the latest data, the latest technology, the innovation. But at the same time, the older versions are still intact with us. We have versatile, highly configurable suite to your use cases. We are accurate. We have location bias, which is most relevant. And the most important piece, we are developer friendly. This means actually you can come, and we believe in startup culture where we want to promote our India, and we believe in Map in India, made in India brand. And this is where we actually encourage our developers to have easy integration and standard response codes so that they can develop, they can leverage our APIs in the best possible way. This brings to a question. I mean, what will you build today with MapmyIndia for a better tomorrow? I just want to think about a situation. I mean, let's understand as a developer, what could be the next best thing which we can do. I'll start with a very simple use case. As a developer, my customer is asking to find all the ATMs which are nearby, and I can do that. If, let's say, there is a problem which is talking about a parking lot, I have to find out parking areas. I can actually go and I can use MapmyIndia's rich data and can actually build my own parking app. Then we have, let's say I want to find a restaurant. These are very basic examples where our data is actually available and you can actually leverage that. Let's say I have broken my phone. What will happen? I need to find a repair shop near me where I can actually go and get my phone repaired. These are very basic things. And I'm going to, let's say, Chandigarh, and I want to have a dhaba nearby with all the things. I can actually find that thing also very easily. I mean, from a developer perspective, I can actually use this API and I can create an entire gamut of use cases and can leverage on top of this information. Moving on to tracking, I want to have a tracking kind of an app. So it is available with our system. You can do a live tracking. You want to go for an enterprise class of asset tracking and fleet management. So that particular backbone is also available where millions of devices and millions of sensors are actually getting the data, and actually it can help you give a better view. I mean, as a developer, let's say I'm the startup and I want to contribute to the community, and I have different ideas, and I want to make my own app. I want to make my own solution. Yes, you can do a wonderful app using the data which is available. You can be a better citizen, and you can take action of your surroundings to alert others. It could be water wastages, electricity failures, lamp posts, mobile network, pipeline, unsafe areas, potholes. I mean, think about it. Under construction building, water logging, what not. So basically, what we are saying is that add powerful location intelligence and mapping functionality to your apps with MapmyIndia's Map APIs. We not only deal with external world, we have a powerful system where we capture the data which is indoor. So within a particular premise, for example, a mall also, you can go and tag your coffee bar or anything else. With this, I want you now to get a flavor of what exactly API is and what are the kind of development friendly things which are available with us. I would like to invite Kunal, who is the product manager for MapmyIndia, and he's taking care of APIs and navigation. Thank you, Kunal. You can continue.
Hello, everyone, and welcome to MapmyIndia's webinar, along with, and we thank AWS also for giving us an opportunity to present our APIs platforms to all of you. And thank you for joining, all of you wonderful developers. Now, just to give a brief example of what all APIs we offer to enable developers to build their own products and services. Some functionalities that we do offer, which you see very often in live realistic worlds, is an example of an auto suggest API, which basically gives you a structured destination input for any query that you put into our search platform. So an auto suggest API works very similar to a type as you go search scenario. Now, coming on to another set of APIs that we offer, this AutoSys, apart from AutoSys API, there are other search APIs also like geocode nearby. All of these APIs, as MapmyIndia, we broadly classify our APIs into 4 different categories. The first of them being map and traffic, where we can customize and view vector maps or raster maps on your mobile platform or on a web platform through different layering mechanisms. Then we offer various controls and gestures on top of these map layers. Apart from that, the next set that we offer is route and navigation APIs, which are we can actually provide you turn-by-turn directions, as well as distance and ETA between 2 points on the map. Coming to the search APIs, this classification of search APIs includes the AutoSys API, which I already mentioned, the geocode API, which actually converts any human readable address, full form human readable address, to a latitude and longitude, a point on the map. Then the telematics APIs, which is powered by a powerful IoT platform to get access to any connected devices or real-world sensors and combine that data to a map platform through our telematics APIs. Coming to a broad classification of what all search APIs we offer. Again, as I already explained, autosuggest is a type as you go search API. Coming to geocode, it converts the complete human readable addresses into geographical coordinates. This is powered by an intelligent algorithm, which is backed up by a professionally curated map data to power our map APIs. And you can leverage our extensive map data to create your own custom solutions for your clients. The next API which we offer in search classification is reverse geocode. Now, the best example use case of a reverse geocode API is when any device or a real world sensor gives you a point, a latitude and longitude on the map, and you want to convert it into a human understandable address. This API, for example, in a logistics or a tracking solution, will give you a human readable address that is reported from a latitude and longitude sent to the server via a tracking device or a real world sensor. The next API, which is extremely powerful again and offers you a very good search algorithm, is nearby API. Now, nearby API can take a location reference and search in a wide variety of categories, what we call as POI categories, point of interest categories, be it petrol stations, be it ATMs, be it banks, be it hospitals near you. Any point near a reference point can be searched via a category, specified using specified category codes, or you can search via human understandable keywords. For example, the search examples which we previously described to you, let's say a dhaba near me, you can simply say you want to search for a restaurant or you want to say search for a hotel. So hotel and restaurant are defined as keywords in this keyword search. Lastly, and most importantly, our ELOC or place details API. Now, a place ID is a unique reference, which we'll explain in the later slides, assigned to any geographical entity on MapmyIndia maps. This API can be used to extract the details of a particular place with the help of its ELOC or place ID. Coming to the next section of APIs, which we say are telematics APIs. Our telematics APIs are extensive, but the four most commonly used APIs are requesting the live location of any vehicle or a device or a real world sensor. We give you the most accurate, precise, and detailed address results using the live location API. The next aspect is trips and drives APIs. Now, trips and drives APIs, what it does is it provides you the list of reported geopositions of a vehicle in a day. A trip or drive by definition means that it's a timeline. It's a journey of where the vehicle or a person went from point A to point B to point C, and it lists the drives between each of those points and gives the track followed by a vehicle or a person for better fuel and expense management. The third API, geofence and route, gives you the list on details of all the geofences. Geofences by definition means a virtually capped area, a virtually defined area, be it a polygon or a circle, in which you want to define the entry and exit alarms or an event generation on the basis of entry and exit of any person, vehicle on the map. So using the geofence APIs, you can request the list or you can create a geofence area on the MapmyIndia map and get an event or alert generated on the basis of the so-called created geofences. Now, the next aspect of telematics API is alerts. Now, alerts requests alerts for a related event, be it an ignition on-off alert, be it a speeding alert, be it a vehicle is idle for a long time, and very frequently used alert, especially in situations currently nowadays, is a panic alert. You might have seen in a lot of cab owners, there's a panic button which generates an alert. Now, how is that alert delivered to any application? This is through the alert API, which requests for alarms and alerts to a related event. The third classification of our APIs are route and navigation. Route API calculates directions between two or more locations by taking latitude and longitude as inputs. It can compute results with or without traffic. By traffic, we mean the live traffic situation which is currently there on the route. In terms of traffic, MapmyIndia has a wide coverage of traffic pan-India. The next API is a distance matrix API, which is very useful for any logistics firms. Now, this API can calculate and provide driving distance, not the aerial distance, the driving distance and time between two or more sets of location inputs, again, with or without inclusion of traffic. To give you an example, I'll give you the examples of all these APIs later. The still map image API, the last API, this simply provides you a still image of a map using latitude and longitude and the zoom level on the map. Coming to the fourth and final classification of APIs are interactive map APIs or raster and vector 3D map SDKs. Now, the most important aspect of using all the above mentioned APIs is to display information on the mobile or on the web platform on the map. So using the interactive map API, you can display reliable and precise maps with real-time traffic flow on a web platform. The raster map SDK is the same component of the interactive map API, but available for Android and iOS apps. You can integrate the raster map SDK in your mobile apps and display the maps, including traffic layer, onto your devices and to your solutions that you offer to your clients. The last, vector map SDK, is a recent development from MapmyIndia. It provides you vector maps. The difference between raster and vector being, while raster gives you only a static image, vector is actually a much more fluidic 3D map, which gives you a full-fledged 3D building model of cities and urban areas. You can rotate the map, you can pan and zoom across the map, you can do multiple interactions on the map using both the SDKs on the mobile platform and using the interactive map SDKs on the web platform. Now, there is a very core aspect of MapmyIndia which we have developed. It's quite unique. It's what you can say is an Aadhaar of addresses, which is the ELOC or a place detail. Now, ELOC for any product or service is a precise open standard digital address. You can create your own ELOC. You can also use the ELOCs offered by MapmyIndia for its place database. It's secure, it's open, and it's shareable, and you can communicate over SMS or social network using web links. Now, what is the use case of an ELOC? It's to basically leverage, you can use the ELOC to leverage a doorstep delivery, government tax compliances. You can do asset management. You can do taxi and pickup and drop off. You can do navigation, or you can add formal and informal addresses to a place using the ELOC. Lastly, MapmyIndia, which we'll talk about soon, is a developers platform offered by MapmyIndia, and we'll talk about more about it later. But let me show you a few demonstrations of our APIs. Now, this is an example of auto-suggest API. I'm searching for a house address, for example, D8 Morris Nagar, and you will soon see, I think there is a lag on the video. You'll soon see on the screens, on your screens. Yeah. You'll soon see on the screens the different results offered by the auto-suggest API, which is type as you go. I'll just do it again. Coming to the next API, which is reverse geocoding. As I mentioned earlier, it is used to translate a point or a latitude and longitude to a human readable address. There is a slight delay in video. And the next API you'll see soon, as you see the reverse geocoding API, it's there, and you'll see a human readable formatted address at the bottom. For any map location, you'll be able to see a full human readable address using just the input of latitude and longitude. Now coming to the next API, which is the route API, it is used to calculate route between two or more sets of start and destination points. You can add optionally via points. You will get multiple routes, not just one route. Depends upon whether you have enabled alternative route options or not. The next API, which we'll show you, is the interactive map API on the web. We have created an animated polyline, which is being used to display the movement of a vehicle on the map. Now this is the MapmyIndia portal. As you can see, we have leveraged our own map APIs, for example, AutoSuggest API, to search for a place. For example, and coming to the next section, I'm reverting to my presentation. Yeah, talking about MapmyIndia, to talk more about MapmyIndia, which is MapmyIndia's developer platform, let me invite my colleague, Ms. Swapnil, who is a member of our marketing team and responsible for strategic partnerships at MapmyIndia.
Hi there, everyone. Now that you have heard us out about MapmyIndia's APIs and SDK offerings and usage, I will discuss a platform with you, which is called MapmyIndia. So MapmyIndia offers a developer's platform which enables you to register yourselves and start using APIs and SDKs that we offer. We currently have two competitions under MapmyIndia, which are Appathon and Adathon. Appathon basically is a competition wherein you can build your own applications, whereas Adathon is wherein you can use your innovative ideas to create advertisements. The basic aim of the competition is to power your apps with location-enabled technology and mapping functionalities. We want you to bring your innovative ideas to life, which is exactly where we think all possibilities are endless for you. Since MapmyIndia offers a wide stack of APIs and SDKs, you can leverage this power of best maps. We want you to build a smarter future to accelerate your own growth, for which many developers across India have been using this platform. The incentives and prizes that we have to offer as a part of this competition are job offers at MapmyIndia. We have cash prizes. We are offering free usage of APIs and SDKs under a commercial plan for 1 year. Also, we are offering an opportunity for participants, the winners, who would get seed funding through MapmyIndia for their own startups. On your screens, you can see the registration page for MapmyIndia, wherein you can register yourselves. We are also socially present over Facebook, LinkedIn, Twitter. You can connect with us. You can also drop in your queries that you may have on MapmyIndia at mapmyindia.com. We would be very happy to resolve all your queries related to this competition. So I hope you have enjoyed as much as we have enjoyed talking to you during this session. We would be sending over a survey to your email addresses, and you can get in touch with us with your queries over it. Uh, we would be opening the session for Q&A now.
Hi, so we see there are a lot of questions there. We're trying to answer as many as possible. However, there are two key takeaway from this. One is the serverless platform from Amazon, for which I've posted the link in the chat to everyone. You could also visit aws.amazon.com/serverless. The idea is that you don't spend your time setting up the infrastructure, rather you focus on running your code. You focus on the feature enhancement of your application. Now the question which is coming is like, how does AWS Lambda will work? Behind the scene, basis on the events, we are going to scale the Lambda function. So you don't really have to create a bigger server. If there are a million invocation, then we are going to execute it millions of times basis on the events or schedule. So there's no provisioning of servers, there's no patching management of server. We take care of the scale and high availability for you. So you really focus on your application. Second aspect of a lot of question we are getting on MapmyIndia API. First of all, I would like to provide the link. It is mapmyindia.com/API. Now, there are a lot of APIs which are free to consume. See, the API model is today in the digital world, I expose my product as an API to you. And the product works under freemium model. That means certain APIs are free to use, and there are something like elog where we map door to door. This kind of services, there are partnership model, there's subscription model, which is something like a pay-per-use model. And then of course, get in touch with us and we can work out how we can work together. There's also funding available, as Swapnil mentioned. So do get in touch with us. Please explore the MapmyIndia API. Once again, it's www.mapmyindia.com/API, and you can start exploring them. You could get in touch with us with the email address. We have your registration details. So we'll send these information to all of you as well. And apart from this, there is also www.appmyindia.com. Please also visit that website. I'll also paste that in the chat window. appmyindia.com. While you're building your app, you can go and explore this. So there are a lot of curiosity around serverless and the API model. So please do get in touch with us and we can answer your individual questions. And there will be a small survey, and we apologize, but there was a slight lag on the slides, which actually make the experience a little bad, but we try to address all of your questions if you reach out to us. With this, we'll close the session. Thank you very much for joining today. Thanks.